In this video, we're going to talk about the key features of a parabola and how to identify them. Okay, this is the equation we're going to use, and what we're looking for is the vertex, the domain, the range, and the axis of symmetry. And I've given you this graph over here so that you can see that we won't always have a graph, and we can find these algebraically, but we can see that our graph will match up. Okay, now there's two ways to do this, and I'm going to show you both, but the way that you will use primarily in my class is completed square form, because generally on test questions you're asked to complete the square first anyway. And so if we were to take this equation here and we were to write it in completed square form, we would have 3 in parentheses x minus 2 squared plus 4. Okay, now if you don't know how to write it in completed square form, go back and watch that video. But once we have it in this form, it's very easy to identify all 4 of these things. Okay, this equation and this equation are the same. They represent the same graph, they're just 2 different forms. Once we have this form, we want to find the vertex. Okay, and the vertex here is the lowest or highest point on the graph. So we could all look at this graph and we could decide that this point was going to be at 2, 4. Okay, we want to list the vertex as a coordinate pair. So we know the vertex is 2, 4. If we didn't have this graph and we wanted to identify it from this equation, notice that this x value is the one in here with the x. So that 2 goes there. Now notice that they are opposite signs. We're doing this as if we were taking x minus 2 and setting it equal to 0 and solving, we would get a positive 2. So you're asking yourself, what makes the inside of this 0? And it's going to have an opposite sign from this one. And then this is our y value, and it's going to be exactly the same. If this is a positive 4, then this will be a positive 4. And if this was negative, then this would be negative. And so that's as easy as it is to identify our vertex. Now our domain for a graph, remember that with domain we're talking about what x values can our graph take. And we should have arrows here because really this parabola just goes on and on. So I'm thinking as I go to the right, how far can I go over for x? Well, if you think about this and you picture this, if this is going to keep going and keep going and keep going, then I can have any x value I want over here, and I could draw a line up, and somewhere up here it would hit my graph. Same thing to the left. This is going to keep going forever, and I could take any of these x values, and then somewhere way up high that we can't see, it would hit my graph. So the domain for a parabola is always going to be all real numbers, because parabolas go on forever. Now, that would be different if we needed to restrict the domain for some specific reason, which we'll talk about later this year. But in general, the domain for a parabola is all real numbers. Now for the range, if domain is x values, for the range we're talking about what y values can I take on. So we're going to look at our y-axis here, and we're going to basically picture this. At this value, I could touch my graph. At this value, I could touch my graph. At this value, I could hit my graph as a y, having a y value. I could go up as far as I wanted because these are arrows, but how far down can I go? Notice that at this point, anything lower than 4, I don't have a graph down there. So looking at a graph, we're matching the range by finding the lowest y value, or if this was flipped, the highest y value. But in this case, it's going to be this number. So we're going to have y and we're going to have this number. What we have to decide is what sign goes in here, because we want to say that the range is either greater than or equal to 4 or less than or equal to 4. Well, since our values are all bigger than 4 because our graph is going up, we're going to say greater than or equal to 4. If our graph was pointed down, then we would say it's less than or equal to 4. Okay, now the way you can decide what the sign is you look at this number right here. If this number in front is positive, then it's going to be greater than or equal to, because that means my graph is going to go up. If this number was to be negative, then we would have flipped this sign and made it less than or equal to. But this number 4 is always where I'm getting this. Okay? Now the axis of symmetry is the line that goes straight down the middle through my vertex. It's a line that basically splits the parabola in half, and if I folded it, these two sides would match up. They would be symmetric. So we're going to write this as an equation. Notice that it hits the x value of 2. Well, our equation is just x equals 2. That's the equation of a vertical line. At 2, which notice is the x value of the vertex, and that will always be the case. So domain for parabolas is all real numbers, but the range you're getting from this number, okay? And the axis of symmetry you're getting from this number. You just have to remember that we write axis of symmetry as x equals 2, or x equals whatever my value is here, and we write the range as y, and then we have to determine our sign, and we take this value. Okay, so that's using completed square form, which is this form, and that's what we'll use primarily in my class. Okay, in this example, you see that we don't actually have a graph, so we're going to go with just using this equation and writing it in completed square form, and we'll be able to answer these questions from that. So if you need to view the video on completed square form, do that. But when we write this one in completed square form, we get y equals -2, parentheses x plus 7 over 2 squared, plus 65 over 2. Now that this is in completed square form, we can identify all of this information. Remember that our vertex is a coordinate, an xy pair, and the x value comes from this, only it's as if we were setting the inside equal to 0 and solving, because if we were going to do that, we would subtract 7/2 from both sides, which would give us x equals -7/2, and that is the x value of our vertex. The y value is this number on the outside here, exactly as you see it. So our y value is 65 over 2, and this is the location of our vertex. Now the domain, again, for any quadratic is all real numbers, unless we restrict the domain, which we will talk about later. The range is what y values can this equation take. So we're going to have y, and we're going to have a y value here, which remember is always this y value of our vertex. The thing we need to consider now is, should this be y is greater than or equal to 65 over 2, or should it be y is less than or equal to? And that's going to depend on whether we have a parabola that goes up or a parabola that goes down. And in this case, we need to look at this number in front of x squared. And since that's negative, we have a parabola that goes down and looks like this. So our vertex then would be at the top, and so all values would be lower than our vertex. So we're going to say y is less than or equal to 65 over 2. And then, of course, our axis of symmetry is x equals, because it is the line, the imaginary line that goes right down the middle here. So x equals the x value of my vertex, -7 over 2. There is one other way to do this. We can find the vertex by using the formula x equals -b over 2a. And if you know the quadratic formula, this is kind of the first part outside of it, and then the denominator there. But this is a formula you can memorize to find the x value of the vertex. So if I wanted to do this, my a would be the number in front of x squared, b would be the number in front of x, which that's a -12 because of the sign, and this is c. So if I was going to use this formula, I could say, okay, x equals, this is -12, but this is opposite of that. So that's like negative, and then in place of b, I get -12 over 2 times whatever my a value is, which is 3. Simplifying this, that double negative makes this a positive. 2 times 3 is 6, and 12 divided by 6 is 2. So we found that our x value was 2, just like before. I'm using the same equation. Now, to find the y value, you have to take this x value and you have to plug it back in everywhere you see x. So what I would do is I would take my equation and I would plug in a 2 every time there's an x in my equation. Don't need that parenthesis. And I would do this math. So 2 squared is 4, times 3 is 12. I'm going to have -24 plus 16. You can do that. And you're going to end up with y equals 4. So then we put our 4 in here. And this would be our vertex. So if you like this way, you can memorize that formula. But for my class, you'll have to be able to complete the square. Again, once you have this vertex, the domain, range, and axis of symmetry, we find the same way. Remember, the domain for a parabola is all real numbers. And the range is going to be y, and we're going to take this value, this 4. Now, here you're looking at this, the one with the term with the x squared. If this number in front is positive, it's going to be greater than or equal to. If that was a -3, it'd be less than or equal to. So we're still using this number though. And the axis of symmetry, we know we write an axis of symmetry as x equals, and we're taking this value, this 2. So all of these answers are the same, but initially we found the vertex in a different manner by knowing this formula, x equals -b over 2a, and then plugging in our x value to find our y value. So that is your other option. That's all for today. Remember to go back and review the Completing the Square video if you need to. See you later.